we're starting a new chapter, and this chapter is going to be on exponential and logarithm functions. And in 7.1, and this will be part 1, there'll be 2 videos. Our first learning target is to graph exponential functions. We did a little bit of this in Algebra 1, but not a lot. And we're going to concentrate first on exponential growth functions. Okay, so let's do some vocabulary. Let's define an exponential function. So the formula for an exponential function has 2 numbers, and the second number has an exponent, has a variable in the exponent spot. And that's when you see an x or another variable up in the exponent, this should cause you to think exponential function. And for this equation, a can't be 0, and b, which is the base, has to be a positive number is a positive number other than 1. Alright, so exponential growth again, if it's growth, the a value has to be greater than 0, and the b value has to be greater than 1. And the b value itself is called the growth factor. So the number that has the x in the exponent, that's called the growth factor. And here we're using the letter b. And if it's growing, it should make sense to you that the number in this position has to be bigger than 1. Otherwise, it won't be growing. Okay? Alright, and then we have a new word that I don't think we've used before, and it's asymptote. Okay, and this will be a part of our graphs of the exponential function. And this is a line. The graph approaches more and more closely. In our case, for exponential graphs, it's not going to cross the asymptote. So it gets really close to it, but doesn't cross it. Alright, so remember, every time we start a new graph, we look at the parent function. And this is the most basic graph of this type. So this is the parent function for exponential growth. You'll notice the a value is missing, and that's just because the a value is equal to 1 here. So we don't have to write that 1 in front. And again, our b value is greater than 1 since it's growth. This is a very general graph because we don't have numbers for b right now. So at 0, if I plug a 0 in and I take a base to the 0 power, remember it's always 1. And then we don't know exactly what this point is, but we're going to call it 1b. Okay, it'll be right here. And you probably remember the basic shape of exponential growth. It starts out really slow and then it grows quickly. In this picture, the x-axis is actually our asymptote. So this is the line that the graph is going to approach more and more closely. It keeps getting closer and closer, but it's not going to cross. Okay? Alright, so in the exponential functions, the asymptote is always a horizontal line. So let's graph another one. Okay, in this one, our A value is 1/4 and our B value is 6. Okay, so you can make a very simple XY table for these. And let's just plug in 0 and 1. If I plug in 0, 6 to the 0 power is 1 times 1/4, so that would just give me 1/4. If I plug in 1, 6 to the first power is 6 times 1/4 would be 6 over 4, and that will reduce to 3/2. Okay, so since we know the basic shape of this graph, we don't really need a lot of points. Alright, 0, 1/4, and 3 over 2 is 1.5, so it'd go about right here. Alright, so remember, close to the asymptote, but make sure when you graph it, it doesn't cross the asymptote. I'll have to take off a point if you make it cross. So again, the x-axis, is our asymptote, and we're going to talk about domain and range on all of these graphs. Domain, we're looking at the x-axis, and eventually, very slowly, this graph is going to cover the whole axis because it'll just keep spreading over the x-axis in both directions. So that will be all reals. But you'll notice on the y values, it's never negative. It's only above the y-axis. So y has to be greater than 0. Can't equal 0 because of that asymptote. Okay, we're going to graph one more on part 1. So this one looks a little more complicated. It's got some right and left movement. The movement that we're concerned about, though, is this up and down movement. This +2 is going to move the asymptote up 2 places. It moves all the points up 2, but the asymptote is going to be the key part. So I want you to draw in that asymptote right away because it helps you define your graph. And so the asymptote isn't going to be the x-axis, now it's going to be up here, up 2 places. And we use a dotted line to represent the asymptote. And so now I know my graph isn't going to cross this asymptote. Alright, so again I'm going to make a very simple XY table, plugging in 0 and 1. Alright, so let's do the work right here. If I plug in x equals 0, and 2 minus 0 is -2, and I want you to go ahead and get the decimal approximation for this. And if I plug that in my calculator, I get 2.2. Okay. If I plug in 1, I would have 0 minus 1, and that would be 3 to the -1 power plus 2, which is approximately 2.7. And this, I also rounded on this one. Okay, so at 0, I'm just a little bit above 2, and at 1, I'm just a little bit under 3. Okay, but again, since we know the shape, and don't cross that asymptote again. So domain, this is again going to cover the x-axis, So it's all reals, but the y values have moved up 2. So now they have to be greater than 2 because there's no y values underneath 2. Okay, and that you know that because of this plus 2 on the outside. And I really want you to practice your domain and range on all of these. And your domain for all of these is going to be all reals, but your range will change. Okay, that's the end of part 1.